Hello, my name is Simon. I'm a Nutanix SE, currently on the federal team. Today, I'm going to provide a demo for you on our NKP solution, Nutanix Kubernetes platform. But before I get into the demo, I'd like to show you just one slide that talks about information on why customers choose NKP and what are some of the things that we're solving with NKP. And so, first, if you think about a CIO mandate for companies to deploy microservices and containerized based applications, that mandate sort of makes those applications become business critical, which means now they need to be supported just like the rest of the applications and infrastructure in the organization. But the challenge most customers have is they don't currently have trained Kubernetes staff that know how to deploy Kubernetes clusters and deploy containerized applications on those Kubernetes clusters. And so, how do we do that without having to hire a bunch of very expensive Kubernetes certified admins? So, I've put together a list of bullets, not necessarily in any order, of some of the operational tasks that need to be done when customers consider deploying containerized apps in Kubernetes. So, first on my list would be things like how should the Kubernetes clusters be configured as far as resources, CPU, memory, and storage, and what applications should we put on those Kubernetes clusters, and how do I take the applications and the code that our developers are working on, how do I get that code deployed onto those Kubernetes clusters? And is it easy to do updates? Is it easy to do patches? And can I restrict access from a security perspective to those applications to certain people via multi-tenancy and with federated environment? Um, and once the applications are running, how do I understand the utilization, resource utilization of my deployed Kubernetes clusters, whether those clusters are on-prem or whether they're in the cloud? If it's on-prem, I certainly don't want to run out of resources like storage. If it's in the cloud, I want to be aware of and cognizant of the amount of clusters that I'm deploying in the cloud because that has a cost impact. And can I prevent waste by having too many clusters deployed, whether it's on-prem or in the cloud? And again, can I secure and lock down not only those Kubernetes clusters, but the applications running there? And how do I update and patch those clusters and the apps and even backup? When you think about data protection, traditional backup solutions are not designed to back up and protect Kubernetes and containerized applications. So how do I take care of that? And if there is a problem that happens in the environment, how do I get insight into what's going on to give me some kind of root cause analysis so that I can resolve the issues quickly? And finally, on my list, I've got financial operations as far as looking at resources and making recommendations for improvements based on a cost perspective with the idea of keeping cost low. And the idea here is that we have developers who are spending time making code and updating code, going from things like QA to production, but we don't really need them to change the way that they are working. We don't need them to be experts in Kubernetes, Kubernetes management, deployment, et cetera. But we do want to give the developers a way to easily move their applications and their code from QA to production through the life cycle of their applications, regardless of whether they're deploying those apps either on-prem or in the cloud, but with a way that allows them to do it consistently and uniformly by simplifying that process. So with that said, I'll come back to this list perhaps a little bit later as we wrap up, but now I'll just jump into the demo environment. So Nutanix NKP solution has the ability to be deployed in the cloud, AWS, Azure, GCP, has the ability to be deployed on bare metal nodes, has the ability to be deployed on VMware ESXi environments, but optionally has the ability to be deployed on a Nutanix cluster. And so since I'm with Nutanix, that's what I'm going to show you today is deploying NKP clusters in the Nutanix environment. So what you're looking at is a traditional Nutanix Prism Central Console where we have infrastructure management for virtual machines, compute, storage, and all of the goodness of Nutanix from an operational controls perspective as far as our self-service, our intelligent operations, our cost governance, our security controls. But today, what I'm going to do is go into the admin center here, and we'll look at the apps that we can deploy, one of them which is NKP. And if I come in here to manage this app, you'll see that we actually run this via a blueprint. So NKP is currently running on this Nutanix cluster that I have. It's running via a blueprint. And I can come here and click this link, go to the console with this default set of credentials that is recommended to change afterwards. And I'll show you some of the identity providers that we support within NKP as we move forward. Before I do that, for those of you that might be familiar with with Nutanix and with our self-service technology as far as how to create a blueprint, if I just simply click on this, it does show you the blueprint that is here. And if we look over here on the virtual machine, we can see the, whether we're running in Linux or Windows, we can see some information here as far as how we configure the virtual machine name, resources, CPU core, memory, that kind of thing, power on state, and some of the guest customization or the script that we might run to do things like install Linux, and what disk do we provide, and what distribution of Linux do we provide. And so this is actually our part of our blueprint. There is a package, there is a service. We can see how many replicas, we can see variables that are running. And the idea with Nutanix is once you create this blueprint, you can then publish that blueprint and launch it. So all of this gets done for you automatically within Nutanix our once we are deploying our NKP solution. So if I go back here and I go to the screen, I can easily click this link to go to the console, and it takes me right into NKP. Once I'm in NKP, I can see a variety of things. On the upper left, you see the Nutanix logo. That's customizable. I put that logo there. It could easily be a customer's company logo. And I put this text in the middle that just says, this is my NKP demo environment. So you can see we can do some customization. Tells me who I'm currently logged in as. And of course, we have different identity providers. So depending on how you might want to connect, whether it's Active Directory, LDAP, SAML, I have the ability to come in here and set up. Is it going to use SSO? What am I going to use for my single source of truth as far as user authentication across the environment? Could even be GitHub. And you can see I can have multiple identity providers and different groups with different role-based administration for access control. So we have the concept of creating a role, a cluster role, or an NKP role that grant different rights to different people with different roles for resources within the environment. And so I can do a lot of things as far as saying, who is going to have access to this environment that I'm about to show you, who can do what, and we can do it at a very granular level, as well as grouping things and creating groups of users with different identity providers, different identity users. So the first thing that I want to do is introduce you to the concept of workspaces. And with workspaces, it's really how we limit who can see what. You can see a lot of different cost information based on these different workspaces. So far, and I'm going to create a new one, and I'll create a new cluster here in a second. We have our management cluster workspace, and we have another workspace that we just simply labeled default. But you can see cost for the last 7 days, total cost in the last day. We can see these different workspaces. So if I go into the default workspace, this is what folks might see when they first jump into the console. And you'd see the number of NKP or Kubernetes clusters that would be deployed with the applications that are deployed on that cluster. And we'll get into projects in a second about what that is and how to deploy it and what that brings to the table and some of the other things that are available. When I do jump into a cluster, so now we're looking at, this is one cluster. It happens to be named workload 01. and it's in the workspace called default workspace. And you can see that it's running on Nutanix here. It's active. We can see some resource utilization information. If I click where it says details, we can actually see a variety of applications that are deployed on this particular cluster. And what I want to do is I want to be able to create another cluster here, kick that off, show you the process to create a cluster, how easy it is, and then we'll come back to what we see on the screen and some of these other things, such as what is a node pool, what are projects, and those kind of things in just a second. So um, if you allow me to go to where it says manage workspaces, you can see here we've got those two. I can create a new one. And I'm going to create this workspace and just simply call it Simon's workspace, give it a description. And I don't really need any annotations or labels for the sake of this demo. I'm just going to create that. It says it's finished. No big deal there. We just created a dashboard. A dashboard, think of it as just a workspace into which I can place Kubernetes clusters and applications on clusters, and I can limit who has access to those clusters and who has access to those applications. Now, before I can create a cluster, I need to, if you look on the left-hand side where the menu is, we have something called infrastructure providers, and I need to create one. And I mentioned that we support all the cloud vendors and the on-prem. So if I was an Amazon shop and I wanted to be able to deploy on Amazon, I would just simply enter my access key for AWS here. Same with Azure, I would just enter my information like my subscription key, tenant key, client ID, secret key. We do support VMware ESXi, so I just can point this to vCenter and give it the credentials to vCenter. Now, I do understand that vCloud Director will be getting deprecated and will go away because of what's the changes with the Broadcom acquisition. So we do also support not only AWS, Azure, but we also support GCP. We also support deploying NKP on bare metal. So we do not need to deploy on a Nutanix cluster. That's optional. But because we can deploy on a Nutanix cluster, I'm going to show you that today. So I'm going to select Nutanix as my provider. Got a couple of clusters. I'm going to choose this one. We typically point it to the Prism Central virtual machine or IP address of the VM. And we enter the credentials. In this case, I'm just going to use admin. I haven't even bothered to set up AD logon credentials, but I'm just going to log in with the admin for now. And I'm going to enter my password to my Prism Central. Now, if I wanted to, I could upload my trust bundle file so that I could deal with certificates and restrict further access, to different folks based on do they have that certificate or not. And so now I have one identity provider that I can deploy a cluster onto. So this was that easy that all I had to do is tell NKP that that Nutanix cluster existed. Now I will be able to deploy a Kubernetes cluster on that. I could have added additional infrastructure providers, AWS, Azure, et cetera, if I wanted to. So I'm not limited. I can have as many infrastructure providers as I like. Staying in this dashboard, workspace, staying in this workspace called Simon. Now, if I go where we say clusters, I can create a cluster. And we have multiple different ways to create a cluster. One of which I can do is this one on the right. I can attach an existing cluster, whether it has network restrictions or not. And I just come in here and give it the name of that existing cluster and I upload the kube config file. And that would allow me to take a customer's current Kubernetes cluster that they already have running in production, add it to Nutanix NKP so that you can benefit that cluster from all the other goodness of what I'm about to show you in this product going forward. Another way that I think is most preferred in production is via a YAML file. I'm not going to do that today. I'm going to do the other option, which is by the GUI. But I think one of the nice things about YAML is it's very granular in its capabilities as far as ability to not only create a cluster, but all the different specifics like what network, what VLAN, what VPC if I'm in the cloud, so on and so forth, as far as how should I create and configure the cluster. I can have multiple YAML files, so I can do things like create t-shirt sizes like small, medium, and large. I could have different types of clusters in a t-shirt size, such as maybe one for a developer that's his QA cluster, another one that's production cluster. I could have one for, different groups, etc. So YAML apparently is the way that folks like to have granularity. And one of the benefits of using a YAML file would be lack of human intervention that could potentially cause human error, right, from fat fingering something, right? So once folks really want to get into automation, from what I understand, YAML would be the way to go. But for today, and especially when customers are starting with this product or learning it or doing a demo or just creating a small environment, we can easily come here and create a cluster through the GUI. So I'm going to call this cluster Simon's NKP cluster 1. We're going to choose our infrastructure provider that we already have. We could use SSH and put credentials in there for security if we wanted to. I can select this project that I have called NTNX, and I can select the cluster, in this case NFIL 002. And within Nutanix clusters, we have the ability to have multiple networks, right? And those networks can also provide DHCP, IP addresses to virtual machines. And then default, we typically name the first network primary and the second one secondary. You can name them whatever you want, but that's what we've done. And so that's what I'm choosing. Now, again, you saw this when I showed you the self-service deployment of the VM, how it had the Linux distribution Rocky. In this case, well, let me just say that customers optionally can choose whatever flavor, whatever version of Linux they choose. If you have an enterprise license agreement with Red Hat and you want to use Red Hat Enterprise Linux, you certainly can optionally do that. If you're an Oracle shop and you have OEL, Oracle Enterprise Linux, or if you choose to use Ubuntu, there are options within NKP to enable you to do that. But out of the box, we ship with Rocky Linux. And when customers choose to use Rocky Linux, it is locked down. It is 100% supported by Nutanix support, but customers cannot modify it. They cannot edit it. But if optionally you want to use one of your own distributions like RHEL, you can do that. You can lock it down, harden that operating system, whatever you want, make that available to be able to deploy here. So the first thing that we're doing when we deploy a cluster is the concept of creating a node pool. And in the node pool would be a couple of things. One is a control plane. And in this control plane, we've got multiple virtual machines. In this case, I could have chosen one VM. That would have been a single point of failure. So if I choose 3 VMs in the control plane, I'm enabling high availability so that if one of the VMs goes down, I still have 2 available. And I'm selecting the resources for CPU, memory, and storage for those virtual machines. And all I have to do is give it an IP address for what do I want the control plane endpoint IP to be. Think of that as like a VIP for these 3 control plane VMs as part of the solution to NKP. And then also we have this worker node pool. And in the worker node pool, again, deploying to the same cluster, deploying on the same network, deploying with the same Linux distribution. I can add Nutanix categories, having the same thing as far as number of VMs. In this case, we're going to go with 4 worker nodes. And here's the resources: 8 vCPU, 32 GB RAM, etc. And if I wanted to, I could do auto scaling. And what auto scaling enables is we monitor the resources in these worker nodes. And when those worker nodes get busy as far as CPU, memory, and storage, we can then deploy automatically additional worker nodes, and I can bump that up to whatever I want. For now, I think I'm just going to not enable it, maybe come back to that later, and I'll just leave it at 4 for now. Then, of course, I can select, because this is Nutanix as a provider, I can select the storage in the Nutanix cluster. And I have the ability to select the Kubernetes load balancing. And so We do provide a load balancer out of the box. Metal LB as the default load balancer that we provide automatically and support. But if customers have their own network load balancer, they can use that, such as an F5 load balancer. Now, the only other thing that I might need to do is punch in here a URL to where to find my registry and punch in a username and password. Type that password in. I could upload a certificate file if I wanted to. And so now I've entered all the information to be able to create my first cluster that I'm going to call Simon NKP, creating a control plane using Rocky Linux, using 3 control plane VMs, and using 4 worker nodes. I'm going to go ahead and click create. And now you can see that it says pending. So while we're waiting a few minutes for this Kubernetes cluster to build, it could take about 10 minutes. What I'm going to do is move out of this workspace that I call Simon and go back to this default workspace so I can show you a little bit more about NKP. So when we come into this workspace, again, you can see the resource utilization. We can see that we're running on Nutanix versions and that kind of thing. I can come here into this workspace and I can look at that cluster that's running in that workspace. In this case, the cluster is called workload 01, which is running in a workspace called default workspace. And we have a variety of applications that are running. Some of them are enabled and some are not. So again, if I look on the left-hand side here in the menu, these are all the applications that are available to NKP as a whole. Some of them are disabled, some are not. I can look at the ones that are disabled and I can actually enable them right here with just simply a click. And one of the things that's very interesting is when you look at all of these applications, you see that it says Nutanix supported. So not only is the infrastructure supported by Nutanix if you're running on Nutanix HCI, hyperconverged infrastructure, if you're running Nutanix NKP, we support NKP, but we also, our support organization supports these applications. So if you have a problem with Grafana logging, you can call Nutanix support and we will help you support those apps as well. So you can see that there's a variety of applications that come out of the box, and you can see that there's different categories from logging, monitoring, security, backup, et cetera, observability. Different types of applications are available, and some of these applications might be categorized as platform, catalog, or custom. Now, currently, I don't have any custom applications, but I want to point out that while we provide applications out of the box, customers do have the ability to include their own customized applications and bring them into this platform, NKP. It's in our documentation on how to do it, but you would simply create a repo and point that repo to NKP so that you would then have all of those applications available here. And then you would be able to, in a given workspace, like the default workspace for the cluster, you would be able to enable those applications for that cluster. Now, what's really nice here is if you look at, for example, Grafana, we talked about once you start to deploy Kubernetes clusters, the need to have certain operational controls, one of those being monitoring. So if I go into Grafana, you'll see from an operational perspective, both real-time and historical graphs and charts and data of CPU memory, storage utilization across all of the workloads, a very nice dashboard, multiple dashboards showing me what's going on as far as network traffic, bandwidth, utilization, however long these clusters have been in use in production and running. And of course, Grafana has many different dashboards available to it. I can scroll and any one of these I could pick. So if I choose the Kubernetes kubelet, you can see all these different application metrics, charts and graphs that are available from an operational control perspective. And again, this is for that particular cluster that was in that particular workspace. So I'm going to go ahead and close Grafana, go back here, and we have Grafana logging as well as the operational control, which logging obviously shows you all the logs of what's happening in the environment, which is helpful for troubleshooting. In addition, what is included is cube cost, which is pretty cool because from a FinOps, financial operations perspective, it's going to show you the cost of what's going on in the environment and show you not only your total cost, but possible areas for savings and cluster efficiency. And you can drill down into these. You can look at all the different namespaces, the clusters, the trends. You can click around and monitor a multitude of different things. And what's interesting is we find folks not only just use this technology as far as what is the cost, and while that's nice to allocate cost to a variety of resources, what's more important is customers tend to use this as far as how can they get more efficient in their environment? Where can they better utilize their resources? Where can they better tweak their clusters, their Kubernetes clusters? And where would it be better from a cost perspective to run those clusters? Would it be better to run on-prem, bare metal, in the cloud, et cetera? And so having that insight, not only while it's nice to give you the financial information, it's even better to give you the information as far as how to be more efficient with the environment. And so if I come back here, you'll see that there's just a lot of applications that are available within this particular cluster. We do have the configuration information, so I can see that as far as what IP addresses for the load balancers. I can see the node pools information. I can see the Linux distribution amount on this configuration tab. I haven't created a project. We'll come to that in a second. And then we have namespaces and node pools. Namespace, you can see there's multiple different namespaces like this default. So every time we create a new cluster, it's going to create a namespace within that workspace. And all the clusters within that workspace are going to share that single namespace. Now, in addition, we have node pool. You saw that when I created the cluster. This is one for the cluster that we call workload one. Again, in this case, we also have 3 control plane VMs, and we have 4 worker VMs. I can come in here and edit. And if I wanted to, I could make changes here, such as I could enable auto scaling and bump that up, or I could change some of the resources here on these VMs that are running Kubernetes. So we've talked about applications. We've talked about some of the apps that get deployed. We also have insights. Insights is very nice from the perspective of if I have a problem in the environment, help me determine what's going on and how to get root cause. A lot of different types of information here, such as availability, best practices, security. If I go to availability, I'll see the things that are in scope that it could be potential issues there, maybe some best practices ones, maybe configuration setting problems or security. And when I look at security, they're categorized as things that are just a notice, things that are warning, and things that are critical to help me better identify where should I prioritize my time on the most critical alerts, with the ability here to click into this detail link to help me figure out not only what's going on from a root cause analysis perspective, but also gives me potential solutions and things that I can look at with links to help me resolve the issue if I need to, right? And of course, you still have the ability to contact support, open up a support case as might be needed. So we've talked about infrastructure providers, we've talked about access control and all the different roles. We've talked about dashboards, and we've talked about clusters. We haven't really talked about projects yet. So one of the things I want to do is go into this Simon workspace that I just created a few minutes ago. And you see that we now have this cluster deployed that we call Simon NKP Cluster 1. I can see it's running on Nutanix, resource utilization. If I click in here, I can see some of the applications that have been deployed. And I see all the different applications that are available that I could enable to that particular cluster if I wanted to. I can see the configuration information. We don't have a project yet. We're going to get ready to do that right now. So let's go ahead and create a project and I'll show you what's going on there. So I'm going to give this guy a project name and I'll just simply call it Simon Project. I don't really need to do any labels or anything, but I select out of all the clusters I have available, which ones do I want to put in in this particular project. So let's go ahead and create that project and we'll go to that project. And once we're in there, we have all these applications that are enabled, disabled, and again, I can enable all the ones that are not disabled and make them available as part of that project. But from a continuous deployment perspective, this is where it really gets good for the developers. So we have the ability to add a GitOps source, and this would be where you would put the URL for a repository for your developers to upload their code, whether it's a branch of their code, submit, et cetera. So the idea here is we don't need developers to be able to create the Kubernetes clusters and manage these clusters. Anybody such as a virtual machine admin, a virtualization admin, infrastructure admin can now be enabled to not only create Kubernetes clusters, but to manage them. We just simply tell the Kubernetes technology how to find the code. And so the developer would just be instructed to upload the code to the certain path where the repository is. And they could upload, for example, going from QA to production and change their code and simply upload it there, and their code would get deployed out to the clusters that are in this workspace for this particular part of the project. So again, in this case, I only have one cluster, but I could have as many clusters as I needed with all the different roles that we talked about, whether I'm an application deployer, an auditor, configuration manager, somebody who manages Kubernetes, or maybe somebody who's a specific application editor, viewer, lots of very granular role capabilities and ability to group those. So you also have role bindings where you can create groups of users and identity providers and group things together. So there's a lot of information and capabilities at a granular level here, config maps, uh, creating secrets and adding key value pairs, that kind of thing if I needed to. One of the things that I think is pretty cool is quota management. So you always want the ability to restrict when you have infrastructure so that things don't get out of control. If it's on-prem, you certainly don't want your on-prem infrastructure getting filled up unnecessarily. If it's in the cloud, you want to be mindful of the cost if people have unlimited ability to deploy into the cloud. So being able to put quotas on things, whether it's a CPU quota or memory quota or storage quota, is very nice from the perspective of limiting what users can do. And you can see it's not just CPU memory storage. There's other things like object count quotas, services, node port services, amount of pods in a given cluster, Kubernetes pods, resources. So I can add all kinds of things, other quotas, different resources and things of that nature that I might want to add. And I also have the ability to do network policies where I can say that maybe based on ingress egress, I might want a policy to allow or deny certain behavior and create an ingress rule to match on certain ports or certain protocols as far as what's going on in the environment, either in ingress egress. And so from a project perspective, once I create a project, I have much more granularity as far as what applications, who has access and roles, who can actually deploy, where is the code deployed for what clusters, which enables me to really manage the environment much more effectively than without, right? So Now let me just go back to my cluster and go to applications here. And you can see if I click on, I think this was the, whoops, I'm gonna need to grab that password one more time. I'm gonna log back into my present console and I'm just gonna go to the area where we had that logon ID and that password, which was right here. So if you remember, I showed you this screen earlier. This was the user ID, and this was the password to not only bring up the NKP console, but when I launch into one of these other applications, it's currently just using that, right? So now I'm running into Grafana. So what I did is I'm in this workspace that we call Simon Workspace. I'm on this cluster that we call Simon NKP Cluster 1 that we just deployed a few minutes ago. These are the applications that automatically got added to that cluster and automatically enabled. I clicked on this blue link here for dashboard. It brought up another page, asked me to authenticate, and then it brings me back into Grafana, which you've seen before. But now you can see the real-time charts and the historical have only just started because I just started this cluster just a few minutes ago. But Grafana is very configurable. I can click on any one of these dashboards um, and see all the information as far as number of running pods, containers, etc., that might be in the environment. So from an observability perspective, it wasn't that hard, right, to build a cluster and jump into that cluster right away and start deploying not only a new Kubernetes cluster, but deploy applications, lock them down, and start to see what's going on in the environment. Now, of course, I bet you if I go into KubeCost, there's probably not a lot of information yet as far as cost because I just started this cluster, unlike the other one that had been running for a little bit longer, right? Um, So if I stay on this workspace, Simon workspace on this cluster, um, we've talked about a variety of different things. The application dashboard, these are the ones that are available, that have been enabled. These are all the applications that may be available that I could enable. Here is information where I can review all of my configuration information, IP addresses for the um, control plane and worker nodes, and then of course my project namespace and node pool. I think we covered most, if not all of this. Again, I think I showed you how you can come in here and um, enable, change things like changing the CPU memory resource, enable auto scaling as an example, coming back into projects, looking at that project and looking at some of the things like continuous deployment, clusters, roles, role bindings, secrets, quota management, network policies. So a wide variety of things that are available here. If I go back to dashboards, and if we look at the main page where we had Nutanix, this is the infrastructure management. We go to NKP. Again, if I go to this particular project, we can see all the different workloads. So we'll see usage for NKP. So this is, I've gotten out of NKP itself and I'm back into the Nutanix Prism Central console, but we're looking at from a perspective of this. We're seeing the workloads that are deployed. So I'm seeing all the Simon VMs that are part of that workload. Seeing any different users, infrastructure. We're using this particular cluster. We're using these networks. I can change things here from an environment perspective or different policies. But one of the things that's interesting is if I go back to infrastructure, and I look at the virtual machines that are on this particular Nutanix cluster, you can see there's a bunch of them, and some of them begin with Simon. These are the ones that are part of that particular cluster. You probably know I can type in here and filter out anything else. So here, what I'm looking at, these are the three control plane VMs. These are the four worker VMs. You can see the difference in the vCPU and memory assignments. But one of the things I think is pretty cool is I told you that not only can we enable scale out, so if the resources on these VMs got to be too high, it would automatically deploy more. But I told you we also have the ability to monitor from a health check perspective all these VMs that are inside this node pool, right? So we currently have four VMs. So if I'm a VM admin and I accidentally delete this VM, it might take a few minutes, but one of the things that you'll notice is the technology monitors itself, and it will eventually deploy a new worker VM. It might take a minute or two, but right now we're down to three VMs. And if you're familiar with Nutanix, you know we have this task capability that we can look at tasks and see what's going on in the environment. So you can see that, I deleted a VM here just a second ago. Well, I'm just going to come back to these VMs, type my name, and just continue to hang out here for just a few minutes. And what you'll see is it will start to create that VM and start to redeploy it for me automatically. So from a high availability, we are protecting your environment, we're protecting your investment, we're protecting a lot of things from fat finger, whether it's the control plane nodes or the worker nodes from a high availability perspective, to ensure if somebody does do something that they shouldn't, that will automatically create the extra VM. So now you can see the other VM got created, but not only did that VM get created, it automatically got re-added to that cluster as part of that workspace. I can come back in here into the tasks, and I can see the create VM task right here. So, and I can see that it succeeded. So I can see all the information about the VM. If I want, I can go and launch the console and make sure that it's okay. I can go into that VM and do whatever I might need to do on that particular VM. If I need to monitor it while it's booting up, I can look at the configurations just to make sure that the disk configuration is the way that I want it. But essentially, we just showed you that we took in that workspace, we took that cluster and we effectively removed one of those four nodes and just basically put it back, right? And we did that automatically without really having to come into NKP to make any changes. So from that perspective, I think I'll finish the demo here. And what we'll do is we'll come back to this one slide just to reiterate some of the bullets here, where we talked about some of the problems, the challenges that customers might have, especially as they're first looking at deploying Kubernetes clusters and containers. From an operational perspective, we bulleted out all the things that you might need to do from a monitoring, security, data protection, insight, financial operations, and we showed you how we can make those changes without involving the developers. So the developers don't need to be experts in Kubernetes management, deploying Kubernetes clusters. We can give that to any sysadmin, virtual machine admin, IT admin to be able to pick up that task. And if they're already a Nutanix admin, it's going to be very easy if you're deploying Kubernetes on Nutanix for them to pick that up. And we give our developers the ability to easily move those applications from QA to production, because if you remember those workspaces that I had, I created one Simon with a cluster in it. That could have easily been a couple of things. I could have had multiple clusters in there where one cluster was for QA and others for production. And the developer simply deploys the code to the QA environment, the QA cluster, and they do their QA testing. And once they know that their code has passed all their QA tests, Now we simply take that code and put it onto the production cluster, and that production cluster could either be on-prem or it could be in the cloud. So this really gives you a lot of flexibility to help your developers if they want to do testing on-prem but deploy in the cloud, vice versa. But it allows them to do it in a way that's consistent and it allows them to do it uniformly in the same way and simplifying the process. So with that, again, my name's Simon Mature, Nutanix SE. Want to thank you for watching. Thank you for your time and hope you have a great day.